Hi guys, welcome to Vedant EduNation. Today I have one more question for you from GATE 2015 Electronics and Communication paper. If you have not subscribed to our channel, please go ahead and subscribe to our channel right now. The question is, the electric field intensity of a plane wave traveling in free space is given by the following expression, which is given here. In this field, consider a square area 10 into 10 square centimeter on a plane x plus y equal to 1. The total time average power passing through the square area is. So, we have to find the total time average power that is passing through the square area x plus y equal to 1, and the area value is 10 into 10 square centimeters. So, this problem, once you look, it is a problem of the Poynting vector. So, in this case we have to find the time average power that is flowing due to the propagation of this wave which is given here. So, first I will find the Poynting vector for this question. So, P is given by P is equal to the Poynting vector is equal to E cross H. Let us just find what is H in this case. So, H can be given can be found out by the electric field which is already given here. The electric field the electric field is in the y direction. That means the H has to be perpendicular to AY, and the wave is propagating in x direction. So, H can be estimated as H is equal to AZ, magnitude is given by the electric field magnitude divided by eta naught, where eta naught is the impedance of the free space and the direction is same as the electric field. So, this is the magnetic field of this wave. So, now let us find what is the Poynting vector here. So, the Poynting vector is given by P is equal to E cross H, that is once I write it down in the matrix form. So, electric field is here. So, the AX component 0, AY component is 24 pi and AZ component is 0 for the electric field, and for the magnetic field. So, this is the electric field, and for the magnetic field AX component is 0, AY component is 0 as well, but AZ component is 24 pi by eta naught, and this gives P as AX 24 pi and 24 pi by eta naught. So, this is the Poynting vector. So, now we have to find out what is the average power that is passing through this plane. So, in order to find the average power passing through this plane, we need to find the vector which is normal to this plane. So, we know that from the vector theory that a normal vector to a plane is given by the differentiation of this of the equation of that plane. So, let us say that so now I am going to find what is the normal vector to this plane. So, if f is equal to x plus y plus 1, then a normal vector to this plane is given by, so n normal is given by differentiation f, which in this case is ax plus ay. So, the unit normal vector in this direction now can be given as n is equal to ax plus ay divided by root 2. This is the unit vector normal to this plane. So, now we found out what is the normal to this plane, and then we have to find out what is the total time average power passing through this square area. So, the time averaged power is given as P dot ds by 2. So, this is the Poynting vector. The half of the Poynting vector is the time averaged power which is passing through that area, and the total time averaged power is given as this. We know what is ds. ds is the surface area of magnitude 0.1 square centimeters, and we know what is the normal vector which is given here. So, this can be written as P dot n dot ds divided by 2. So, the time average power now becomes P is given here, it is Ax into 24 pi into 24 pi by 120 pi, since we know that eta naught equal to 120 pi, and n the normal vector is Ax plus Ay divided by root 2, and there is a 2 here which we put it here, and then the area of this square of the square is 0.1 into 0.1. So, if we solve this by taking out by multiplying the by taking the dot product of Ax and Ax here, and Ax into Ay is 0, this turns out to be 50.0533 watt. And so, once we solve this, we find that the total time averaged power is 0.0533 watt. Okay, so this is the right answer for this question. Thanks for watching. Please subscribe to our channel, and I have given the YouTube video that describes how to find the normal to a plane, like given a equation of a plane, how to find a normal to that. So, that is given in a different YouTube video which I have put it in the description below, and also check out the other books I suggest for studying electromagnetics for GATE.